count wind chill factor and everything else. So usually when it's 0 degrees, it won't happen.
So is there always somebody, like one person always here just to make sure?
There's usually, there doesn't have to be anyone here, it just does its own thing.
Mark was off island for a week and I didn't even come up to visit the poor telescope.
It rained for the whole week, see, so...
How do you monitor if there's anything out there? How do you monitor what's out there?
Ask JD that, I don't even do any astronomy, so...
For weather, you mean, or the...
What's going on there? How do you know? Do you get any warnings about something? Or
like asteroids or things like that? Oh, okay. So supernova. Okay, there are groups that look for supernova. Okay, they're usually surveys. Sometimes they'll have specific areas of the sky they watch, or pan stars tries to get the whole sky in a week or two. And they, when they find something, they have it available to scientists that are working with them, or sometimes they're they broadcast it to all scientists. And if you know where to look on the web, you can find announcements that, hey, there are some near-Earth asteroid candidates. Can somebody go look for them, like Anthony did? And so, or if we're looking for exoplanets, like Connor did, the exoplanets, what they was from the exoplanet he detected was from a satellite program, and I got myself on there by working with some of the guys from Las Cumbres. They said, hey, that sounds like a great program, some neat EPO that we can claim for the telescope, and also some, we get observations as well. So this sounds like a win-win for us. If you guys want to do that, great, go for it. So they let me have access to their website where they have the candidate exoplanets. So
it's less monitoring, it's more looking for something.
Yeah, this is not a telescope that's typically used for monitoring. It's more of a follow-up or targeted observations. The Pan-STARRS Observatory, which was on the right-hand side as you came in, that's a survey telescope, so it's a monitoring type of telescope. Yes, they do. Not on Saturday, which is the only reason we're not going there today. But next time you come up, we'll try to get you in there as well.
Is it possible to see any images of such as you've done?
Sure.
Yeah. Sure. On the websites. On the websites.
Yeah.
You can log on to the LCO website or even Pan-STARRS. They've got images available there. You can see what they do.
What I told people before you came here is, just email Becky. I'll make sure she gets the web address for most of the images. And then if you want to see some real serious science images, get hold of me directly, and in fact we can have him working on some real science. This is the time, the University of Hawaii's time on this is for use by kids. It is for education and outreach. Yeah, we can do some kind of project if he's interested in doing serious science. Yes, I love it. Am I lying?
You'll love it.
Yeah, there's always room for more. What I want to do is kids that are really interested in doing it, that want to do serious science. That's the main thing. When the rest of the Las Cumbres network gets online, we'll use that for a lot of the prettier images. Or what I like to do with kids, they just want to look at the sky, connect with nature that way. I like to put them, I get them up, the amateur astronomer groups that like guys, go out to a school or something and let kids actually look through the telescope.
Velcro.
Okay?
So how do they, I'm sorry, how do you contact, like, say my daughter's
would I go back?
You get hold of me, and Becky's got my email address, and she knows how to keep poking me enough that I get back to you. If I don't get back to you by email, I'm very busy. It's not that it's not important, but things fall off the radar, even important things. So just keep emailing me until I don't. The university is very archaic about that. Becky's got my contact information. JD. Just tell her the problem guy over at the telescope. The problem child.
No.
Except for someone at Los Cumbres, we got to put our own title.
No.
Someone already took problem child. That's why I do it. Someone else also took Jedi Master, so I can't do that.
I had a problem with the locking mechanism
Oh,
and the
I asked
enclosure.
you last time.
They didn't actually have a fixated pin.
A website.
What was actually
to
happening?
find out more about
Pin would actually
how to get
fall right out.
information about lightings.
And then what was important?
Probably what you would want to do is email me, and I will.
We did, that's what I mean.
Yeah, again, send me an email. I'll get you Joe's email address. We had somebody last week contact us because of the talk saying, hey, I'm the treasurer for this complex.
That was me.
We're looking at what
Steve Goldsmith. Hi, JD.
And did Joe get back to you?
He did. He was great. He's got his company. I can forward you that.
Yeah.
He said he heard the noise.
So, and yeah, the Maui Lighting Board, they are there partially to help people make good lighting decisions. And what's nice is most of the good lighting decisions are also energy efficient, cost efficient. That's the way it's going. It's not always that way. All right.
One of the biggest problems with, it's very nice, JD mentioned before that it's very nice to have instruments on here where you can actually swing around and everything else during a session. You know, whereas bigger telescopes will only have one instrument, you know, and schedule their observations accordingly for that one instrument. But the slewing time takes a long time and it takes you off sky because it only actually slews around about 2 degrees per minute. So there's benefits and there's pluses and minuses to everything. One of the other problems with this is when we actually take the telescope apart to like do the primary mirror like JD mentioned before, is we have to take off every instrument. That is a big job because they all have to be realigned and everything else when they're put back on. As of June this year, we will not be doing it. We'll be able to actually hopefully take the whole of this off with the instruments on it and including this and pull the whole lot out live, put it on the floor and leave it all powered up and go and do our work that we have to do inside it.
So you mentioned that this is for targeted viewing objects.
Yes.
What are some examples of what it's looking at?
Asteroids, in particular near-Earth asteroids. These are the ones that can come up and blindside us. In fact, last month may have been earlier this month, we had Dr. Dave Folan, who is a leading researcher in asteroids. We got him some data on an asteroid that has a projected possible collision with Earth in 2668. So coming up real soon.
Oh, when we balance the budget.
But there are other asteroids that have had potential collisions with Earth that we've observed with this telescope. I don't think any of them we've ruled out, that the data from this telescope has been the ones that have ruled out the collisions.
So it's mostly asteroids?
Well, that's the first thing. That's asteroids. Connor did a science fair project on exoplanets, planets orbiting other stars. And he actually was one of the, his observations were key in determining that it was an exoplanet, not a double star, not a binary star. We have a group at Maui High School that is working with supernova data, so stars that blew up. And
It's an interesting supernova at the moment that was actually observed on Earth 18th century, 1840s.
What was?
A supernova
Oh, yes.
that they're actually re-observing now.
Yeah.
Might ask what? How?
Yeah.
Easy, it reflected off a dust cloud, and now they're seeing the whole supernova over again with modern instruments.
Another supernova remnant that we tend to look at is, does anyone know the Crab Nebula? That makes a really pretty picture. But there's been some science done by Dr. Edward Gomez, who was working with a student. I think it might have been his niece. They went through the data, the images that had been taken of the Crab Nebula and measured the velocity of some of the wisps that you see in there, and they were moving at something like 8% of the speed of light. Now that is really fast. That's faster than anything man has ever made. Well, except for colliders. You know, a couple atoms, okay. But faster than any craft. Go ahead. Flashlight, okay, yes.
I was wondering, over there's an instrument. It was on the island.
So what is the instrument over there? You want to tell them about that? Little one over here.
So you compare binoculars?
The binoculars?
Also look at comets.
Yes.
Binoculars are just doing
Stephanie Spear is a student who has worked with comets. No, actually, she's working with asteroids. Gina was working with comets. And she's a student, high school student over on Oahu. And I know that Heather Kaluna is also working with a younger student on comets. And in fact, to do the class of comets, you're familiar with the main belt of asteroids? Some of these, we're beginning to see them and say, oh, wait a minute, that's a comet. You know, we see a coma and sometimes a tail. And so Heather, who's a graduate student, born and raised on the Big Island, she's one of our favorite success stories, but she's a brilliant scientist in her own right. She's working with students, and the students are working on these comets, these main belt comets. What's interesting is we're trying to figure out where water came from on Earth. We thought it came from normal comets, but they have the wrong isotopic abundances. So now we're looking for other sources. We probably should be out there looking and seeing if Becky's coming back.